Okay, so this is 8.1, day number 2. We're going to talk about graphing logs and exponentials and talking about their domains. I've got a problem on the next page that I'm going to skip for now, but we can talk about that later. How likely? Okay, so I want to graph this function 2 to the power of x, okay? And what I'm always going to use here when graphing this is I'm going to use the points -1, 0, and 1, and you'll start to see why as we go. So 2 to the power of x. If I plug in a -1, what's 2 to the power of -1? Same as 1 over what? 1/2, right? So anything to the power of 0 is 1, and 2 to the power of 1 is 2. So I'm going to sketch this graph. I'm going to sketch the point 0, 1, which comes up a lot. You'll see that happen quite a bit. And then I'm going to plot the point -1, 1/2, and the point 1, 2. So here's an exponential function called y equals 2 to the x. Okay. Is that growing or decaying? Growing, right? Growth, right? The 2 is greater than 1, therefore it's going to grow. If this were 1/2 to the x, it'd mean it half it each time. You guys recognize the term half-life? I'm sure you do. Okay, so let's talk about this for just a moment. As x goes to -infinity, what happens to y? What does it approach? Out here, it's going to 0. It never equals 0. That's interesting. And as x goes off to the right forever, y increases exponentially. Therefore, infinity. So what is our domain of 2 to the x? Yes, our domain would be all real numbers, right? And our range would be 0 to infinity. So what would the inverse domain and range be? Flip them, right? So 0 to infinity and all real numbers, or -infinity to infinity. I want to show you what the inverse would look like. I'm going to show you how to get there. I'm actually going to stay on this slide. Bless you. How did we find the inverse of a function? What do we do with x and y to start? Flip them. Flip them. And then solve for y, right? Well, gosh darn it, how do I done solve for y? Look at that thing. I can't just bring it down. Well, yes, you can. If you do, oh, hello. If you do what? Well, I'm going to take the log of both sides. I'm going to take the log down there of both sides, base 2. Why did I didn't do that? You're going to see. Why you going to do that stuff? So check it out. If I look at this for just a second, everything to the right, what would that have to equal? 2 to what power gives me 2 to the y? Yeah, it'd have to equal y. Oh, look at that. I isolated it. That's the inverse. Log base 2 of x. Log base 2 of x. Right? Because 2 to the what power equals 2 to the y. Well, that would have to be y. Therefore, this evaluates to just y. And that's our inverse. Now, I'm going to sketch that inverse in just a moment. We'll get some more repetition in and you'll know. You'll get it. Okay, so I know the domain of this new function, this inverse, is 0 to infinity, and the range is -infinity to infinity. So what is the other thing that we know about inverses and their points? Take these and do what with them? I'm going to flip them. So instead of -1, comma 1/2, I'm going to have 1/2 -1. And instead of 0, 1, I'm going to have 1, 0. And instead of 1, 2, I'm going to have 2, 1. Let's sketch this and see what it looks like. All right, you guys, I want to show you a couple different ways to do this. First of all, here's one way you can do it. Here's e to the x. I think we can all agree that this is e to the x. Here is e to the negative x. Now, if I took and I reflected that, that would look like this, vertically. Do you agree that this would be negative e to the negative x? You okay with that? So I did first I did a horizontal reflection. Then I took that new function and I did a vertical reflection. So let me show you in a different way here. You have options here, guys, but the thing you need to do is you need to be accurate with your values. If I multiply by -1, I get 1, 0, -1. If I multiply this by -1, I get -1 over e, -1, and -e. Now, if I were to plot these points, negative or +1, -1 over e would be right about here. 0, -1 would be right here. And -1, -e would be right here. So, in general, you can do your transformations on the numbers, or you can just intuitively look at it and say, okay, if I reflected it left then down or right then down, this is what it would look like. Either way, you'll get that same point or that same point. Here would be the graph of e to the x. Okay, so that would be y equals e to the x. Its inverse would just be the following. And there's natural log of x. Alright, so what is this +3 mean to our function? Yeah, left 3, right? Horizontal shift left 3. So if we graph this and then shifted it left 3, we should be right on par, right? So first what I would do is I would draw the table of values for y equals 4 to the x. Why would I do that? Why would I do this? Why would I do that? Why? So this gives me these values for my inverse. These two now become 1, 4, -1, 1, 0, and 4, 1 for log base 4 of x. Now could I take these values and could I shift them to the left 3? Yeah. What would I do to these? Not +3, what am I thinking? -3. This would be a shift 3. So if I subtract 3 from 1 4, I get -2.75. If I subtract 3 from 1, I get -2. And if I subtract 3 from 4, I get 1. So now I get these new set of points. -2.75, -1, -2, 0, and 1. Is that 1, 1? Okay, so 1, 1. -2, 0. -2, 0. And -2.75, -1. Okay, now what do we know about logarithms? They always have what kind of asymptote? Vertical asymptote. Where is that vertical asymptote? Well, it used to be at 0. Now it's at -3. So this would be y equals. Okay. Now so far, is that okay? Yeah. All right, now let's go a little bit further out. Let's sketch these transformations here. What's happening horizontally? It's the only thing happening horizontally. Yep, so we'll multiply by -1. Okay, so that would make this +1, 0, and -1. What's happening vertically? Shift and reflection. Which one has to come first? Has to come first. Reflection. Okay, so I'm going to do those things to these items. I'm going to multiply by -1. And then I'm going to add 8. Now, I don't know what -1/e plus 8 is, but I do know it's -1/e plus 8, which is a little less than 8. And then 8 minus 1 is 7, and 8 minus e is 8 minus e. So let's sketch these points. 1, comma, a little less than 8. 1, comma, a little less than 8. There's that point. -1, comma, 7. And -e, comma, 8 minus e. -e is a little less than 3. 8 minus e will be a little bit more than 5. Okay, what you're going to notice, you guys, is that there's a horizontal asymptote at 8. Why? Because this graph has been flipped over and shifted up. So it's going to approach 8. And that would be a nice general sketch. Okay, hold on. Let's go back. Thank you, 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 thank you. Okay, is that, okay, we're back there. So then it should have been 0, 7, right? And -1 and a little bit more than 5. Thank you. That was good. Just dissecting you there. This should be here.